In the previous unit, we talked all about slope and rate of change and how that is represented in equations, tables, and graphs. So whenever we were writing equations, we always wrote equations that were proportional or direct variation equations. So in this unit, we're going to be focusing on that extra piece that shows up in equations sometimes, and that's the constant that's added on at the end. So if we talk about just like any general equation that we've looked at, the number that we're focusing on now is going to be this constant at the end. So the plus 5 in this equation I just made up. So that number is called the initial value. It's the corresponding y value when x is 0. So this would form an ordered pair. You can find the initial value of a function from tables, graphs, or words. So this number that's added at the end, whatever it might be, is part of an ordered pair where 0 is the x value. So whatever the number value of y is when x is 0, that's the initial value. So we're going to look at this in a few different examples and just kind of check and see how we can find this number from tables and graphs mainly. So in this first example, Grace is planning to have her birthday party at a skating rink. The rink charges a party fee plus an additional charge for each guest. So here we have a party fee, which is going to be paid once, and then once that's paid, we're going to have an additional charge for each guest. So there's some words that tell us where the rate of change is, and here that amount per guest is our rate of change. The first thing we want to know is the total cost proportional to the number of guests? And so whenever we were trying to see if something was proportional or not, we took a single ordered pair and we did y divided by x. If all of those ratios matched, that made it proportional. So from this table, let's say we just focus on those first two ordered pairs. So 153 and 256. So I'm going to check the ratio of these first 2 points in this table to see whether it's proportional or not. So to find the ratio, I take the y value and divide it by the x value. So in this first ordered pair, I do 53 divided by 1. And so the ratio of the first ordered pair is 53. Now let's check and see if the second ordered pair has the same ratio. So for this one, whenever I do y divided by x, I have 56 divided by 2, and that's going to give me 28. So the first ratio is 53, and the second ratio is 28. So this one is not proportional because there isn't a constant ratio. All right, so since there's not a constant ratio, that means that there has to be an initial value. So in order to find that initial value, the first thing we're going to need to find is the constant rate of change. So as the number of guests increases by 1, what happens to the total cost? This is asking for me to find the rate of change from this table. So when we're finding rate of change, we did change of y over change of x. So instead of using a single point now, we need at least 2 points to find that change. So in the table, we can find our change of x and our change of y by looking at how it's moving as we go through the table. So if I look down through my x values, I notice that each time it's going up by 1. So as the number of guests increase by 1, we need to know what's happening to the cost. So for my first jump, it's going from 53 to 56, so that's going up by 3. And then from 56 to 59 goes up 3. 59 to 62 goes up 3, and that pattern continues. So each time the number of guests increases by 1, what happens to the total cost? It increases by 3. So the cost increases by $3. All right, so just to put this into rate of change, we would do change of y divided by change of x. This one doesn't change any because our x values were already going up by 1 in the table. But typically we will need to divide it out and make sure that that's going to match. So now that we have this, we need to think about knowing that it's not proportional and that there will be an initial value, but we don't know what that initial value is yet. So we need to think about how we could find the total cost for 0 guests without having to use an equation. So if I look at this table, what I'm going to do is I'm going to kind of create another little cell up here. So just in place, in part of the title, just to make myself some more room, I'm just going to create another cell in this table, because right above the 1 there would be a 0 for the X value, and that would represent 0 guessed. So if I think about the pattern that I see happening in this table and how I could go backwards, I can reverse the operation. So to go from 1 guest to 0 guest, that's going to take 1 away. And from my rate of change, I know that each increase by 1 guest makes the total cost go up by 3. So if I take a guest away, that's going to take $3 off of the cost. So if I do 53 minus 3, that's going to give me an initial value of 50. So what we can do is we can use the rate of change to work backwards to x equals 0. So now we're going to look at how we can put this into the equation. So we know that the rate of change, since it's telling you how something changes, it's going to go with the variable, which is the thing that changes. So my rate of change was 3, so to write the equation, I'm going to put the 3 in front of the x. Now I'm going to use my initial value as the second number, and the initial value is the y value when x equals 0. So if you look in the table and you see a 0, the number that goes with it is what's going to be added at the end of the equation. So in this case, $50 is kind of the starting point. It's our initial value. So based on this situation that we were given, this is going to be the party fee. So the party fee was $50, and then each person that came added $3 onto the total cost. So that party fee only gets paid one time. So that's kind of represented by no guest coming. You have to pay $50 before any guests come. So our initial value is that constant that's added on at the end. All right, so we're going to look at another example here. And this one is about a savings account. So the table shows how much money Ava has saved. We're going to determine the initial amount of money that Ava had in her savings account. And we have to assume that the relationship is linear, which means that it'll keep the same pattern as it goes. It'll have a constant rate of change. So the first thing we need to do is to find that rate of change. So here we have the points in a table, and to find the rate of change, we really just need to look between 2 of those points. So let's say that we're going to use these first 2 points. So the ordered pairs for these points are 3, 110, and 4, 130. So we can find the slope from the table, or we can use our slope formula. So in the previous unit, we talked about the slope formula, which was the second y minus the first y over the second x minus the first x. So if I use this formula, I'm going to take that second y value and subtract that first y value. So on top, 130 minus 110. And then for the bottom, it's going to be the second x value minus the first x value. So that'll be 4 minus 3. So if I simplify this down, 130 minus 110 is going to give me 20. And then 4 minus 3 is 1. So my last thing is always to divide that out. And 20 divided by 1 is 20. So that's using the slope formula, but you also could have used your table and found the change on each side of that table. Either way, we get this same answer, and we find that Ava saves $20 each month. So remember that your rate of change is something that's happening each time. So here it's each month. Now that we know this information, we're going to determine how much money Ava had in her savings account in the very beginning. So that's going to correspond to 0 months as an X value. So I know that each time the month went up by 1, her savings account grew by $20. So if I want to fill in this table back to 0, what I'm going to do is I'm going to take off a month at a time, and that's going to take $20 back out of the account. So if I take off a month, I have to take off $20. So 110 minus 20 will give me $90 in the account. After 2 months, I'm going to march back another month. So that'll take another $20 out of the account. So after 1 month, she had $70. We have one more step to go, so $20 more taken out of that account. 70 minus 20 is 50. So when I finally reach 0 as my X value, the Y value is my initial value. So Ava initially had $50 in her savings account. So we just need to figure out which place each of these numbers go by thinking about what each one represents. So the first box is for our constant rate of change, or our slope, which we use M to represent. And the constant at the end is the initial value because it only happens once. All right, so $20 each month. That word tells me that it's going to go beside the variable. And then the 50 is matched up with 0 in the table, so that's going to go at the end. So the equation that would represent this situation is y equals 20x plus 50. The next example we look at is going to start out represented as a graph. So in this graph, this is the number of membership points based on a reward program at a shoe store. So a new shoe store is offering free points to customers who sign up for their rewards card. Then for each pair of shoes a customer buys, they earn an additional number of points. So the graph shows the total number of points earned, and we're going to determine the amount of points that they're offering initially. So before we do anything, we need to choose 2 points from this graph in order to find the rate of change. So we can choose any 2 of these 4 points. So I'm going to choose 490 and 150. So I choose 2 points from that graph in order to find the rate of change. So I'm just going to write down that slope formula again. Second y minus first y over second x minus first x. And then I'm going to plug those numbers in. So the second y is 150. And I'm going to subtract the first y, which was 90. And that goes on the top. And then on the bottom, the second x, which is 8, minus the first x, which is 4. So I plug my numbers into my formula and then I simplify. So 150 minus 90 is 60. And 8 minus 4 is 4. So the final step to finding that rate of change is to divide. So 60 divided by 4 is 15. So that means that for each pair purchased, a customer earns 15 points. So now that's my rate of change. If I think about where that goes in the equation, that's going to be the number that goes in front of the variable. Next, we need to find that initial value. So to find the initial value, if I take the first point that's shown on the graph, which is at 260, I'm going to use this rate of change to walk my way back to where x is 0. So that would represent 0 shoes purchased, and the number that is left over is going to be the initial amount of points that you can earn. So if 2 pairs of shoes have 60 points, and each pair of shoes earns you 15 points, each time I walk myself back one, I'm going to have to take 15 points off of that total. So I'm going to do 60 minus 15, and that's going to tell me that after 1 pair of shoes is purchased, the account has 45 points in it. So I need to go back one more to get back to 0, and 45 minus 15 is 30. So that tells me that when x is 1, y is 45, and when x is 0, y is 30. So the initial value of points earned is 30 points. So when you open your reward account and you haven't purchased any shoes yet, you automatically get those 30 points just for signing up. So that initial value goes as a constant at the end of the equation. So the number of membership points you have can be represented by the equation y equals 15x plus 30, because you get 15 points per shoe purchased plus a 30